And now we have the live demonstration, first of mini-FLOTAC and then on KFM, based on the work performed by my collaborators in the lab, and Antonio Bosco and Lavinia Ciuca will start with the mini-FLOTAC live demonstration. So go ahead, please.
Hello again. So as Laura mentioned, today we are going to analyze a fecal sample from cattle using the mini-FLOTAC technique. So we will go through all the steps. I will start by saying that mini-FLOTAC technique, as you already know, it's aimed to perform multivalent qualitative diagnosis of helminth and protozoan infections both in animals and humans. So without further details, I will start by listing the equipments and materials that we need for processing the fecal sample of cattle. So first time, it's our device, mini-FLOTAC and field-FLOTAC, as Antonio is showing now. Then we will need the flotation solution, which is zinc sulfate with a specific gravity of 1350. And then we will need the wooden spatula for homogenize the sample, the tip for the field-FLOTAC in order to fill the chambers, and the timer because we are going to wait 10 minutes and then translate and analyzing at the microscope. So the first step is to add 45 milliliter of zinc sulfate in the field-FLOTAC beaker. Then Antonio will fill the conical collector of the field-FLOTAC with 5 grams of feces and level the surface. But before, as is already showing, it's very important to carefully homogenize the fecal sample because the eggs are not distributed homogeneously. So before filling the conical collector, in this way we will avoid the false negative results. So now he will fill with 5 grams. And then level the surface as I already mentioned. So the further step will be to homogenize thoroughly the suspension. In this step, it's very important to accurately homogenize the sample to ensure that all the sample is mixed with the solution, and also to be careful to avoid the formation of too many bubbles. Okay, so the further step will be that Antonio will put the tip on the lateral hole of the field-FLOTAC, because in this way we will fill both chambers of the mini-FLOTAC. But before that, he has to invert 5 times in order to mix very well the sample, and then squeeze it in order to fill the flotation chambers. We will do this mixed inversion 5 times. Each time we'll fill the first and then the second chamber. We will see that he will fill it in this way, in the manner that we will form the little meniscus, because in this way we will avoid also the air bubble that will enter in the chamber. Then the last step will be to wait after 10 minutes. But for the sake of the time, today we already prepared another mini-FLOTAC, so we will not wait 10 minutes. And go ahead, Antonio, you will translate now. Remove the key after the translation. Okay? And then he will examine our sample under the microscope. Okay, so Antonio will place the mini-FLOTAC on the microscope adapter with the ruled grid of chamber number 1 on the right. And then focusing on the grid and start from one corner and count the parasitic elements in all 12 columns of the first chamber, and then we will repeat the count for the second chamber. So as we can see here, we have already some elements of Eimeria oocysts. We have a lot of artifacts as well, plant matters, debris, pollen, but those are artifacts that we can find it also with other techniques. Here we have also some eggshells of fasciola, but also some gastrointestinal eggs, as we can see. A lot of artifacts again here in this image. We have an image where is fasciola and paraphistoma, both of them, and also some Eimeria oocysts. As we can see here, there are the eggshells of the liver in rumen flux, so it's different in comparison with other techniques, for example sedimentation or flux finder, where we can see the whole egg. Now, when we are gathering the final results of mini-FLOTAC and calculate the X per gram, we have to add the dilution ratio that we used, which is 10, divide with 2, and this would represent the final count of the X per gram for our sample. So we can find here multiple parasitic elements in the sample. Okay, that would be all from our side. Thank you.
Welcome everybody. Now we continue with another practical demonstration on Kubic FLOTAC microscope, where Giuseppe and I will illustrate the operation step of KFM. The KFM, as the name suggests, is a cubic, is a compact and weighs only 4 kilograms. It is composed by a mechanical part and shows the movement of the slide tray. First, a slide tray can produce it from the device in which it houses the mini-FLOTAC or FLOTAC. An optical part consisting of LED lights and digital camera scanning of the device. The KFM can operate without a power source for several hours, approximately 3 hours, as it is equipped with a lithium battery. The KFM can be connected to PC, laptop, smartphone or tablet by Wi-Fi. On the back side of KFM there are 2 USB ports and Ethernet port to allow the possibility to connection in straight Wi-Fi. On the back there is also the power plug for charging the device. To begin, the first step is to press the switch for 3 seconds and the blue light stops. To connect the KFM to the laptop, like these cases, open the Wi-Fi control panel and select CAP-FM Wi-Fi. After connection, open the browser, go to this web address 192.168.4.1, log in by entering the password. Okay, in this way we obtained the interface of KFM. The inject command permits to extract the slide out tray of KFM. In this way we can insert the mini-FLOTAC or FLOTAC devices. Now we can add the mini-FLOTAC in this way. Okay. After we can press the load command to recall slide out tray. When the mini-FLOTAC is inside, processed to automatic positioning in the cases of mini-FLOTAC. Press command M home or FLOTAC F home to start the automated scan and the system position the device to the start reading position. So, the next step is focus with the grid. Focus is adjusted according to the bubble in the mini-FLOTAC's chamber using the micro and the macro focus routes. In the cases we see the both eggshell of Chalicophorus dabney and shell egg of Fasciola hepatica, and you can see the egg of a gastrointestinal nematode and some oocystis of Emeria. In the Autodect menu, select the Autoscan command to start scanning. You can press yes to continue. In this way, the CAP-FM captured the 192 frames in 6 minutes. At the end of the session, a zip file is generated and downloaded. After this step, internet connection is required to send the zip file to the external service for egg identification. Enter farm information in the report info by clicking on the upload zip command. In this way we can have example. Scan name is prepared farm, samples ID 1, farmer, for example La Falode is our cattle farm of project Prepara, referent Laura Rinaldi, affiliation Cremopar, scan place laboratory, technician Antonio Bosco, host species cattle, device in this case is mini-FLOTAC, the technique is basic, dilution ratio 1:10, and you see only number of chamber 1. Click on upload. After submit the files, the external server sends us the report after approximately 10 minutes. This is an example of a report in which there are the farm data, we complied early, and the parasitological results with the general species and the EPG values. In these cases, we see the positive of the Chalicophorus dabney with the EPG values of 40 EPG. For Fasciola hepatica, the positivity is 10 EPG, and for the gastrointestinal nematode 50 EPG. In this report also you can see the total camera image resulting from the image concatenation and the detail of each individual scan to verify the eggs detect. As can be seen, the KFM can be used on the farm without internet connection or power supply, but in order to get the report connection is required for egg identification. Thank you for your attention. We now finish the practical part. Thank you.